Hello and welcome back to the Maths Behind the Economics YouTube channel. This is video 16 in the Exponents for Economics series, and this is the last video when we're concentrating on how exponents work in economics. Again, in this video, we'll be working with expressions, formulas, and calculations which are using letters, variables, which are most common in economics. Again, I will explain at each step which exponent rule I'm using and why. So, let us get started. Here comes our first question. Bracket open, 3p squared q to the negative 2 to the 4. Another bracket opens, 2p to the negative 2, q to the 4, bracket closed, and all of it is to the third power. Right, so what are we doing in this question? Well, I've got two brackets. There is nothing in between the brackets, so that means I'm going to have to multiply those two brackets together. But inside each of the brackets, I have got combinations of different letters and numbers. Can't really do anything within the bracket, but what I've noticed is that each of these brackets are raised to a power. Namely, the first is to the fourth and the second is to the third. So what we can do is raise individually each terms inside those brackets to the named powers. So I can do 3 to the 4, and then I can do p squared to the 4, and then I can do q to the negative 2 to the 4. Then carry on, I can do 2 cubed, and then I can do p to the negative 2 cubed, and q to the 4 cubed. Okay, now I have got individual powers to the power, which means I'm gonna have to multiply those exponents together. So 3 to the 4 stays, but now the new power of p is going to be 2 times 4, which is 8. The new power of the q is going to be negative 8, because negative 2 times 4 makes negative 8. 2 cubed stays. Then the next term is p to the negative 2 to the third, so that's going to be p to the negative 6th. And the last is q to the 4 cubed. That's altogether going to make it q to the 12, because 3 times 4 makes 12. Okay, now, what's going on in here? I have got nothing in between these letters and numbers. That means that everything is multiplied together. So I can rearrange this in a slightly different order. So I can do 3 to the 4 times 2 cubed, and within the numbers I always want to write out the multiplication sign so I don't mistake a multiplication for a double digit number. Then I'm going to collect the p's and q's into order, so I'm going to have p to the 8, then p to the negative 6, then q to the negative 8, and q to the 12. Now I can do this because in multiplication I can switch the order around without making any difference or any change to the final answer of that multiplication. Now, why did I do this? Because I actually wanted to see better what powers I can combine together. So I'm going to keep 3 to the 4 times 2 cubed for the moment. And then p to the 8 times p to the negative 6. Well, I've just got the same bases. Multiply them together means I'm going to have to add the powers together. Now, I'm going to skip writing out the power addition, because I know that 8 plus negative 6 just simply cancels down to 2. Then I'll do the same with q, because again I multiply the same bases together. So q to the negative 8 times q to the 12 means I'm going to have to add negative 8 and 12 together to find the new power, and negative 8 at 12 is yielding 4. And that is my solution. The last thing I could do if I really wanted to do is to pick up the calculator and calculate 3 to the 4 times 2 cubed. That's altogether giving me 648 p squared q to the 4. So that is the solution for these two long bracketed multiplications. Next question. K to the 2/3 multiplied by k to the 4/3 plus k to the 1/3. Okay, so what are we going to do here? Well, inside the bracket, I have got k to the 4/3 plus k to the 1/3, even though these two terms have got the same basis, k. Because I have got them different powers, 4/3 and 1/3, I cannot simply add them together. So I cannot simplify what's inside the bracket, because it's like adding oranges and apples together. I can't add them together. They're going to be still different things. So what I need to do, I need to multiply out the bracket. So I need to multiply the terms inside the bracket individually by the term outside the bracket. So k to the 2/3 have to be multiplied by k to the 4/3 plus k to the 2/3 have to be multiplied by k to the 1/3. So what's going on in here? Well, I've got the same bases, but I'm multiplying them together with different powers. So again, I have to add those powers together. Just like in previous videos, let's switch color and do the fraction addition separately. So 2/3 add 4/3. Well, I'm in luck because they have got the common denominator already. So all I need to do is add together 2 and 4 to make 6/3. And 6/3 conveniently cancels down to 2. Now, let's deal with the other powers. 2/3 add 1/3. Well, again, same denominator, so I'm just going to have to add the numerators together. 2 plus 1 makes it 3. 3 divided by 3 gives me 1. So let's go back to the original question. So the power of k in the first term is going to be 2, because adding together 2/3 and 4/3 will cancel down to 2. And in the second term, because adding 2/3 and 1/3 together makes it 1, I can replace it with k by itself, because any base to the first power is just itself, as we've seen in a previous video. And this is how I'm going to leave the answer, because k squared and k are two different quantities. It is definitely not equal to k cubed. Remember, k cubed is k times k times k by the definition, and k squared plus k is not equal to k cubed. Okay, let's make a bit more space and then look at the next question. It's going to be a long fraction. In the numerator, I'm going to have 3p1 squared x1 cubed, and at the bottom, I'm going to have 2p1 to the negative 2 and x1 squared. Well, I made the fraction a little bit too long. Now let's see what we can do. Now, before I go into the algebra, let's talk a little bit about the indexes. I have got an index down here in P, and I have got an index up here in P. Now, what's the difference? Well, the index in the top, the green highlighted index, is the exponent, is the power. The yellow highlighted index, that's just a notation. That's telling me that somewhere in the question or somewhere further in the practice calculations, I'm going to have another letter P, which will mean something slightly different. So very often in economics questions, once you start to have more than one product, then you can start to talk about the prices and the quantities of different products. So very often P1 would represent the price of good 1, and for example P2 would represent the price of good 2, or P3 for the price of good 3. What's important for us here is that these indexes down at the bottom right hand corner, the one that I highlighted with yellow, are not part of the calculations. Those notations don't represent some specific mathematical calculations. Write the green ones up in the corner. So throughout the calculation, these lower corner indices are going to be part of the notation. I'm not going to do any calculations with them. I'm just going to bring them along for the ride. These upper corner notations, these indices up there, the green indices, are the indices that are telling me which powers I'm working with. Those are the notations that I'm using for the power exponent calculation. Okay, so let's keep going. What do I have here? I have got here P1 up in the numerator and down in the denominator, and I also have got x1 up in the numerator and down in the denominator. So because I'm dividing those, I'm going to subtract the powers. So 3 over 2 I can't do anything with, but what will be the final power of P1? That's going to be 2 take away negative 2. Don't forget that you have got the negative power in here. Then what's going to be the power of x1? The power of x1 in the numerator is 3 and in the denominator is 2, so I'm going to just take away 2 from 3. Right, so 3 over 2 stays, and then P1 in the power, I've got 2 take away negative 2, so that's going to be the fourth power at the end, and x1's power is just going to be 1. Now, one last thing I can do, remembering that anything to the first power is just itself, I can lose that little annoying 1 in the upper corner, and then I can make my notation a little bit clearer. Okay, so the important thing here is that in economics, you have got these lower indices, lower notations, and they don't form part of the calculation. So what you need to do is just bring them along for the ride. They just distinguish in between different variables. So in economics, P, P1, and P2 would all signify a slightly different variable. They are all prices, but they are prices of different goods. So P would be generally the price, P1 could be the price of good 1, and P2 could be the price of good 2. Right, I hope I haven't over-explained it, and if you have been clear about this distinction in the notation, then I hope you didn't mind this short revision. Right, let's move on to the next question. P to the negative 2 over P to the negative half, bracket closed, multiplied by P to the 6 to the 1/3, and then multiplied by Q cubed. Okay, so what's going on in here? Well, I have got two brackets, so I need to deal with the brackets first. What's inside the first bracket is a fraction, and in that fraction I have got the same letter P in the numerator and the denominator, which means that I'm dividing the same bases together, so I'm going to have to subtract the powers. So that's going to be P negative 2 take away negative half. In the second bracket, I have got an exponent raised to an exponent. So what I'm going to have to do here is I have to multiply 6 and 1/3 together, because that is the rule for raising an exponent to an exponent. Well, Q cubed is just Q cubed. I can't do anything with it. Next thing is to deal with the fraction subtraction on the side. Well, taking away a negative number is the same as adding. So actually what I need to do is negative 2 add a half. And again, how I'm adding fractions together is bringing them to the common denominator. So negative 2 is negative 4 over 2 plus a half is going to give me negative 3 over 2, because negative 4 plus 1 makes it negative 3. So the first P's exponent is now going to be negative 3 over 2, and the next P's power is going to be 6 times a third. And let's do a quick calculations on the side of it that as well. So 6 times 1/3, when you multiply a fraction with a whole number, you just multiply the numerator of the fraction with that whole number. So that's going to give me 6/3, but 6/3 conveniently cancels down to 2. So the second P's power is just going to be 2, and Q cubed is just coming along for the ride. Last calculation I need to do here is, because I'm multiplying the same base powers P again, I'm going to have to add minus 3 over 2 and 2 together. Q cubed is still just tagging along. Make a bit more space again. Also switch color, and I'm going to do minus 3 over 2 plus 2 on the side up here. So minus 3 over 2 is going to stay as it is, plus 2 is 4 over 2, and then that's together going to make it a half. So the final power of P is going to be P to the half, and Q is just going to stay 3, right? This was our last exponents question. Well, if you found these videos useful and you think you could benefit from similar videos in the logarithms theme, then come along with me for a journey into logarithm land in the next set of video series. See you there. Bye.